Welcome to the second in a series of videos looking at Level 3 electrical design, cable selection. Today we're taking a look at how we choose the rating of our protective device. The next step in our circuit design is to select an appropriate protective device type and rating. Usually we will need to select a protective device to protect against overload currents as well as fault currents. Each type of overcurrent has a specific symbol. IN is the rated current or current setting of the protected device, sometimes referred to as operating current, and this is the overload protection. IPF, the prospective fault current, sometimes referred to as the breaking capacity of a protective device, is how much fault current it can safely disconnect. On the pictures on the right, we can see a picture of a fuse and a picture of a circuit breaker. On the fuse, you may see where it says 25A, so that's 25 amps, that is the IN rating, or the operating current. The 80kA, up on the top right of the device, is the IPF, or the breaking capacity. So this fuse is designed to operate over 25 amps, and it can safely do so up to 80,000 amps. For our next part of cable selection calculation, we refer to BS 7671 2018. Regulation 433.1.1 Indent 1 tells us the rated current or current setting of the protective device, IN, is not less than the design current, IB, of the circuit. This gives us this little formula that is shown in BS 7671. In the last video we looked at how we calculate design current. Now we need to understand we need to choose a protective device which is either greater than or equal to IB. This is simply because we have a load which will give us our design current, so for example a load of 15 amps. We wouldn't choose a protective device less than that, so say 12 amps or 10 amps, because our protective device would operate when our load is trying to operate under normal conditions. Therefore our formula to start off with is IB should be less than or equal to IN. Before we choose our rating of device, we should know which type we require to protect our load. For the purposes of this short video, we're just going to concentrate on circuit breakers, and in particular the modern types. The table shown, 7.2.7, is from the IET on-site guide, and shows circuit breaker types with the trip currents and their applications. We'll concentrate on the modern types of circuit breakers, so type Bs, Cs and Ds. We can see type Bs, their applications are domestic and commercial installations having little or no switch-in surge. Type Cs are for general use in commercial industrial installations, in situations where we may experience switch-in surges. And then type Ds are not suitable for general use, and they're suitable for transformers, X-ray machines, industrial welding equipment, anywhere where we may expect high inrush currents to occur. We can see the trip current ratings in the central column, and it says for a B type that the trip current is 3 to 5 IN. What this means is it should trip at 3 to 5 times the rated current of the protected device. So for example, for instantaneous disconnection of a type B6, you would need 30 amps, so 5 times 6, 30. For a type C, we can see it's 5 to 10 times IN, so for instantaneous disconnection for a type C6 would be 60 amps. And then for type D, we can see for instantaneous disconnection, we would need 120 amps, 20 times IN. One for type B circuit breakers to BS EN 60898 and the overcurrent characteristics of RCBOs to BS EN 61009-1. And then similar for type C and then type D. Under each of these rows, we have the rating of the protected device and then the maximum ZS value. All we currently need is to choose a suitable protective device rating, remembering that our protective device rating should be greater than our design current. So let's have a look at a couple of examples. Number 1, select an appropriate protective device type and rating for a circuit supplying an electric oven in a dwelling having a design current of 13.04 amps. Remembering, again, IB should be less than or equal to IN. If we look at the types we might need, it says in our example there is an electric oven in a dwelling. A dwelling would be classed as a domestic premises. So if we look at the snippet of the table from the on-site guide, we have circuit breakers type B are suitable for domestic and commercial installations having little or no switch-in surge. So we would select a type B. And then looking at the rating, We have a design current of 13.04 amps, and we know we must choose a protective device which is equal to or above this. If we look at the ratings of protective devices under Type B circuit breakers, we can see the one just above 13.04 amps is 16 amps. Given that this is for an electric oven in a dwelling, we're going to select an RCBO, so a BS-EN 61009-1 B16. Next example is to select an appropriate protective device type and rating for a circuit supplying an X-ray machine having a design current of 26.03 amps. Again, looking at the tables from the on-site guide, we can see that the Type D is suitable for transformers X-ray machines, so we will choose Type D. Looking at the table from BS7671, we can see the different ratings of Type D circuit breakers. We look at our design current, which is 26.03 amps. Look along the line and we can see that we have a 25 amp Type D, which would be too small because it would be less than IB. So we need the next size up. So that's going to be a 32. Therefore, I'm going to choose this time, because we've got an X-ray machine in a commercial premises, probably not going to have any need for an RCD protection. So we're going to choose a BS-EN 60898 miniature circuit breaker and Type D rating 32 amps. So now we've looked at calculating design current and how we select our protective device rating and type. Join us next time when we'll move on to identifying rating factors and calculating the required current carrying capacity of our circuit conductors. See you soon.